Hello everyone, this is the class 18 lab. We're gonna characterize the inductor here. So we need to build this circuit, right? In this circuit, we have 8 millihenry inductor and 100 ohm resistor here. Then we have a signal generator as input. And so right here, I have a signal generator. If you come here, signal generator, importing the signal to the circuit. Then over here, this is the 8 millihenry inductor and the 100 ohms. There's the circuit right here. So input, I'm using channel 1 for the oscilloscope to measure the input that's coming out from signal generator, and output across this resistor here. So output across the resistor here, you can see that this is the channel 2 measuring, output across the resistor, right? So let's set your signal generator here. I need 1 kilohertz frequency. So frequency should be 1 kilohertz right here, good. And then I need 0 to 5 volts min and max. That means I need 5 volts peak to peak with 2.5 offset. So next one is 5 volts peak to peak. That should be square wave, right? Peak to peak, and offset should be 2.5. So 2.5 volt DC offset. So that will give you what I'm looking for, right? So 0 to 5 volts min and max, 320 duty cycle, and 1 kilohertz. You have a duty cycle over here. At least this is a 50% here. Duty cycle, right? All good. So now turn it on. So now if you turn it on, I'm going to try to press this. Okay, now look at here. So this is the one. This is the input signal coming out. Let me make it both of them in the same scale so I can compare them. So both are 2 volts scale there. So bring them here. So now this is the output. The channel 2 here. This is the output across the resistor. This is the input, right? Input is square wave. Ignore this bump over here. This is because of inductive circuit is doing some bump because of inductive circuit. Ignore that. So this is square wave, and this is the voltage across the load 100 ohm resistor. So if I draw them over here, right? If I draw them, this is input is look like this, 0 volts, 5 volts, right? Your output across the resistor is look like this, right? Like that, right? This is the output V out across the resistor. It's a 50. My drawing doesn't look like 50%. It's 50% duty cycle. So like that, right? So now you know that across the resistor, your voltage and current are proportional, right? So if you look at here, if you look at the peak to peak for the channel 2, I can see that is 3.10 volts. That means voltage across the resistor, when is high, is 3.10 volts. I divide by that. So if I try to find the current for here is 3.10 volts over 100 ohm, right? That will give you 0.0310 amps, right? 3 milliamps. So this current has different magnitude, but should follow the wave of the voltage across the resistor, because across the resistor, the voltage and current, they're proportional to each other. It's because of Ohm's law, right? So now your current wave should follow 50. I'm going to try to make 50% here. Should follow the same pattern right? But the magnitude would be, for my measurement, 310 amps, right? So that is the current of the inductor. That's the same current going through inductor. That means that inductor cannot change. This is the same current. This is the, look at here, the series circuit, right? The series circuit, right? So the current should be same everywhere. So current going through the resistor, same current coming through the inductor. So that means this is the current going through the inductor. This is also the inductor current because of series circuit, right? So that means current in inductor cannot change instantaneously, because that it takes time to increase takes time to decrease, right? So current in inductor cannot change instantaneously. That's the key point here. So that's what we're trying to show you. The current through the inductor cannot change instantaneously. Look at here. It's not instantaneous. All right, that's all for the part one. We're going to get to the part two.